We're going to show that if you draw two tangents from an external point, then the distance from that external point to where those tangents hit the circle are going to be equal. So first of all, let's just draw the diagram to make sure that everyone can see what it is we're trying to prove. So first we'll draw our circle with a centre, and then we'll draw a tangent from an external point. To remind you, a tangent is a line that touches the circle at one point only. Effectively, it's like a stick resting on a wheel. It's only touching it at the point where it rests. So let's draw our second tangent now. It can be in any old place as long as those two lines cross, the two tangents cross. And then we'll draw two radii from the centre out to the tangents. And we'll see later that those two tangents join the radii at right angles. The last line we're going to draw is from the centre out through where the two tangents cross at the external point. And we're going to label up our points now. So the external point where the tangents start from is point D. Then we have the 2 points where the tangents touch the circle, points A and point C, and the centre of the circle at point B. Notice that what we have now are two triangles. One triangle ABD and the other triangle BCD. And we're going to use some facts about those triangles to prove what we're trying to prove. First off, let's notice that the lines AB and BC are the same length. They're a radius of the circle, therefore by definition they're the same length. And also that the line BD is common in both triangles. We also know that where a radius touches a tangent, that angle is a right angle. So the angles at A and at C are right angles, 90 degrees. So we have two triangles here, and they have two sides and one angle the same. This means that those triangles are congruent. That means, in mathematical terms, that they're identical. If the triangles are identical, that means that the third side of each of them, AD and DC, must be the same and equal. And that's what we were trying to prove in the first place, that tangents drawn to a circle from an external point are equal in length. As with all circle theorem proofs, we've used a couple of existing pieces of knowledge allied to our knowledge of triangles and put them all together to come up with a new proof.